AWS basics, and it's going to be a combined effort of sorts, right? We are going to learn theory about certain aspects of AWS, not the whole AWS, because even the AWS basics for certification, it's like 1 week course, right? About 45 hours of learning, and we have only 1 or 2. So we are going to be focusing specifically on the parts that would allow you to create an OPSBridge POC. So it means that we'll be taking certain shortcuts in our definitions because, well, you're not going to get AWS certification, but you need to press those buttons, and those buttons need to produce a result that you want from them, right? So everything is going to be attached to the OPSBridge in the cloud, or containerized OPSBridge POC in the cloud. That is the AWS perspective that we're going to take, and we are going to combine it with a really short demo of the AWS console itself once we establish the theoretical pieces. Now, in case you are already aware about everything that I'm going to say, that's completely fine. What we're trying to achieve is not to teach you everything in one go and then say, well, you know, I already taught you that, so you should know it. That's not what we're trying to achieve. All of the exercises would be showing you exactly which buttons to press and what to do. But in this presentation, we are going to establish a common vocabulary between those that already know AWS and those that are just learning. The idea is to get ourselves a conversation that is both effective and on topic. And we found that that's the best way to do it. So please relax, sit back. You're not expected to be tested on what you're about to see, but it will help you to understand that, well, I see this function and exercise or something like that, and we already spoke about it. So there is some relationship, something that pops in your mind when you see it, so you would not be surprised. Okay, so that being said, let's discuss. So on the agenda, we will define the cloud itself, and we'll define some of the basic skills for the OPSBridge deployment and operation. Okay, AWS is vast. There's like 73 services at the moment, and we will need just like 5. Okay, so first of all, why do you need to learn AWS in general, and uh, why use it in general, right? So there is a big difference between the on-prem environments that are managed by IT and cloud environments that are too managed or controlled by IT, but then access level normally is very, very different, and your needs are very, very different. So you will be more, well, you'll be exposed more to the platform in case of AWS rather than, let's say, VMware-based platform when you do an on-prem for a customer, right? That's one thing. Another thing that, you must learn the cloud, and every cloud in particular separately from others, is because the terminology is different between all of them, right? So we might say Kubernetes cluster in on-prem environment, but in AWS is going to be EKS, and Azure is going to be AKS, and so on. So when people are talking about same mechanisms, but in different locations, you do want to be aware about where they are logically at this specific moment, right? So terminology is very important. There is also a growing trend of infrastructure as a code, which means that instead of using normal IT services where you say, well, you know what, guys, I need like 5 machines this big and several ports open on the network, and then you just get the username and password and you work away. Nowadays, there is a lot of infrastructure as a code. It means that the specifications for what is about to be created are coming together with the product, and you do need to be aware about them, right? So it's not just that you ask for several machines, you're actually asking for permissions to create those machines, be it automatically or manually. So there's a lot of awareness that needs to grow about the normal product operation, okay? The security is tighter, but you're also exposed to more parts of it. So definitely need to be aware about that in every single platform, especially in the cloud. And of course, well, we already said that, but more control. When you go to the cloud, even if your customer would try to restrict your rights in terms of what you get to operate, there is still plenty of things that you get to control compared to a normal on-prem environment. Okay, so this is the why. Now, we are going to make some assumptions because we cannot just assume that it is your first Micro Focus course and you have never operated OPSBridge before, or you have never operated a multi-tiered environment, something complex, right? This is not a presentations for those that never heard about the cloud or OPSBridge. It's a presentation for those that heard about the functionality and used some of it, but now they will get to use some hands-on on AWS itself. Many of you have seen the platform one way or another, be it YouTube videos or anywhere else. However, not many of you got to do some hands on it. Okay, so we assume that you know what we're talking about, at least in terms of complexities of big applications. You know what OPSBridge is, because well, it cannot be combined in the same presentation. All right, so first of all, let's try to define the cloud. As you see, when you go to Wikipedia, they struggle with it a lot. This is how they greet you. This article may be confusing or unclear to users. So let's try to define the cloud using Alexei terminology, which is my preferred terminology, right? So what is a cloud? It's basically tons of IT stuff mashed together, and you get to rent it. Okay, now of course it's not as easy as that. When you go to the cloud itself to operate it, you'll see that it's very, very, very convenient compared to normal infrastructure. And the reason is, well, that's what they sell. They sell convenience and speed. And it means that they create nice UI, great workflows for achieving your goals, great tools for just making everything automatic and nice. So the cloud is basically a bunch of stuff that you can operate with much convenience and more control at the tip of your fingers, while having less people or less distribution of effort, right? So if in the past there was like DBA people and infrastructure people and networking people and storage people, now you get to touch many of those components. So they offload some of the expertise to the cloud itself, but some of it is actually exposed to you more than usual. Okay, and it's all based on pay-per-use. So whatever you use, you're going to pay for it. Anything that you're going to use is going to cost money. Now, when we want to get away from ideal terms and realistic terms, okay, so basically it is the same. Okay, it depends on your access level. If you are an admin in the on-prem environment or in a standard data center environment, when you compare it to the cloud, you get the same benefits. Okay, you still get Kubernetes, you still get storage, networking, and everything. The way that you control it is more convenient in the cloud. Okay, it is very pleasant to operate the cloud compared to, let's say, VMware and all of the backend stuff. Okay, and though basically the idea of the cloud is just to give you access to those things more conveniently, while trying to separate maintenance at least from administration. Okay, and still it's based on pay-per-use. This is the main theme of the week. How do we save the costs? Okay, now let's compare it a little bit. I'm going to start actually with something that's called VPC, Virtual Private Cloud. We are going to get back to it on technical terms, but I'm putting it here up front, even before we get to touch the cloud, because it is going to be the governing factor in everything that you do. VPC, Virtual Private Cloud, it means that every single VPC is considered to be a separate virtual private cloud or virtual data center. Even if you are hosted at the same location, but there are two VPCs in them, the logic of them being separated is the same as them being on different planets for all intents and purposes. Okay, and you can stress it enough. Most of the mistakes that we had to fix on infrastructure level were dealing with people choosing the wrong VPC. Unfortunately, in the cloud, you get access to many more resources that you need to use. And it means that you can place your stuff in the wrong VPC, and then you'll be investigating what's wrong until you notice this really small string of letters in some of the configurations, which indicates that you are in the wrong place, right? So let's talk about this. In the normal data center, there is network 1, network 2, and they cannot see each other. But normally also it's configured in a way that allows you to understand that they cannot speak. Okay, there is this hierarchical structure that doesn't let you see all of them at the same location, right? Now, in AWS, it's the same deal, but they are not separated visually. So here's one of the, well, of course, a simplistic example. There are many examples where it's just a mix of them between those two extremes, but still, in the normal VMware infrastructure, you'll see there is cluster A and cluster B, and in most approaches, you would know that that they cannot talk to each other. That's the visual cue or visual clue when you operate the vCenter. And in many cases, you wouldn't even see the stuff that you cannot control. It allows access control on that level, and it's easily done. Now, in AWS, it's a little bit different. Unless someone took very specific care about blocking things that you should not be seeing, and it's not trivial, it's not just done with one click of a button, you would be exposed to everybody else. And here's an example. This screenshot of just the VM machines in AWS includes like 3 or 4 VPCs, basically 4 different data centers, and they're all in the same place. And the only way for you to understand it is by actually using search and filters, okay? This is something that we need to also get off my chest right now. Type everything that you can. If there is a search bar, that's where you go first. You never go for a drop-down list without typing. You never click a button without filtering out the contents. Otherwise, you're going to get lost, and you're going to be spending lots of time on operating the environment rather than getting the value that you want. Okay, so in terms of VPCs, they can be on different continents, on the moon, different providers, same idea. If this is not the same VPC, you should be treating them as if they have no connection, unless you perform some intentional steps to make them connect to each other. Okay, but on normal terms, if you did not take special measures, they cannot see each other. All right, and now we can get to talk about the AWS itself. So let's start with zones and regions. So when we talk about zones, you'll see, when we talk about regions, when you'll go to AWS, you'll see that you get to choose in what region you are going to operate at the specific moment. Now, for this course, we chose to operate in Oregon. It wasn't a conscious choice from us. It just happened, but it's Oregon. And you might see that if you're familiar with the cloud, a couple of data centers here are missing. I think South Africa and Bahrain are not here, and probably something else that is missing. But those are the regions in AWS. Now, every region has also a concept of availability zone. Availability zones are basically separate data centers. So one region can have multiple data centers. I think I saw 3 or 4 already. And they're going to be named A, B, C, D, something like that. And those are physically separate locations inside the region. Okay, so if we use the diagram here, You see that every region has a number in it, and this number represents the number of availability zones inside it, which means that for Oregon, there are 3 physically separated data centers that to you appear as a small drop-down menu for every resource where you get to select where it goes, but those are actually different data centers. Very important, because some of the functionality of AWS is going to be dependent on you understanding in what availability zone you are at the moment. Now, VPC in more general terms or technical terms, well, virtual private clouds, which is basically a networking configuration. It has subnets, some routing tables, gateways, NAT gateways that allow you to communicate between availability zones inside the same region. Normal things like DHCPs or firewalls, security groups, we're going to be discussing that separately, and some other configurations that basically allow you to operate your network. And it's not just for IT. It's not just the IT guys that are going to be touching it. You are going to be touching it as part of the OPSB or let's say ITOM platform and life cycle. You are going to operate it in general terms, although not for everything, but you need to be aware about the specific configurations. You need to be aware about the security setup. You need to be aware about what was set up in the VPC. And considering that we're going to be using a Cloud Toolkit, the Cloud Toolkit would be creating this VPC. So it's not a manual process for you, and it's not as restricted as it would be on-prem. Basically, you create a whole separate network by just typing a couple of commands in terminal, right? So let's have ourselves a little bit of a short demo for a VPC, just so you will see that while visually this is not the same as VMware, let's say, still the concepts or the terminology that you're going to see is still very much like you're used to it. Okay, so this is the AWS console. On a default EC2 view, those are VMs, and we need to navigate to VPC. So the way to switch between services inside the AWS is by using the search bar. Okay, I'm typing VPC, and also I'm opening in a separate tab. Why? Because I like hopping between tabs. It is much faster to operate things this way. When we will go to VPCs right now, because we had cleaned them up before you guys arrived here, there are not too many of them, but all of those are separate VPCs. So you'll see there is a student 23, there is student 83. Those are our test labs for building the course. And when you click on it, let's say we'll go to manage the VPC. Can we really edit it? Not too much, right? You can edit CIDRs, edit DHCP, DNS, host names. We can go to subnets, and let's say I want to filter it by, let's say, student 23. You see, if there is a search bar, use it. It's going to be a repeating theme. Then I can separate and see that all of those nice subnets we're creating, every subnet would have a bunch of their own configurations here. You can get the details. You can see the routing tables that are attached, some rules for network ACL, CIDR reservations in case you want to be controlling what is yours. And then you can go to route tables, internet gateways, and we're not going to be discussing them in detail. What we're going to, what I'm trying to show here is that while the UI is very AWS related, right? The concepts of networking are still the same. There are still DHCPs, there are still subnets, routing tables, gateways, there are VPNs, which we're not going to use. Many of those things are actually coming from the normal words. And one of the interesting things is, for example, elastic IPs. This is where you can get and allocate IP addresses that AWS is not allowed to change. So a little bit of theory here. When you create resources I'm not going to say VMs, when you create resources with public addresses, AWS reserves the right to change the address, the public one, not the internal one, anytime they want according to their needs. So for example, if you create a database server and it has a public DNS name and public IP name, AWS can just change it in any day, and any application that was connected using the public details might get disconnected now. So for example, if you want to avoid that, you can go to AWS and say, you know what, I'm going to allocate some elastic IP addresses. Okay, and to me, it means that to AWS, it means that I'm going to be paying like $5 a month to not have the IP address change, but I do need to attach this IP address to the desired resource, right? So it is very important because in AWS, we cannot turn off and on the machines unless they have elastic IPs, meaning that every machine, every VM, here in instances, we're going to be talking about instances in a few minutes. In case I turn off a machine, power it down, when I power it up, the public IP that I used to connect to it, or when I used to integrate it with other stuff, would be changed by AWS unless I attach an elastic IP to it. Okay, so as you see, we're already starting to see some differences in approach towards the cloud. VMware treats every machine as if this machine has a full life cycle. You can turn it on, turn it off, you can reboot it, you can create all kinds of state in it, and you get to keep your settings when you want, not in the cloud. In the cloud, the consideration is, spin up things fast, use them, utilize them, delete them when you don't need them anymore, so we wouldn't be paying more money. So many of considerations, many of the axioms around operating it are evolving around that. Not everything here is set in stone. You don't need a subnet, delete the subnet. You need something else, create it. That's more or less the idea. So to recap the VPC, VPC is a definition of a whole network with all of the internal rules, subnets, and everything that allows it to operate in one or more availability zones to provide you the convenience of internal addressing, external access, and interconnectivity with other entities, be it inside the cloud or the internet. Fantastic. Now we will go to EC2. Now EC2, well, it's a VM manager. You're going to be spending most of your time in EC2. And this is where you create VMs. This is where you manage VMs. This is where you get the details of those VMs. And you can do several things like snapshots, security groups. You can deal with storage and with load balancing. And we're going to be giving special attention to load balancing in the EC2 realm, right? So what is EC2? Well, a bunch of virtual machines. Okay, for example, you have a screenshot here. All machines are just lines inside this mechanism. And when you select every machine, you get access to some of the details that are going to be crucial for you. For example, the internal or external addresses. You would be aware about what VPC this machine belongs to. Okay, and you can also deal a lot with security, and we're not going to be doing anything else with those machines in the context of OPSBridge. And from experience, there's not much for you to do in the normal EC2 machine operation beyond the detail, security, and networking tabs. Okay, now what are images? In the AWS realm, images are basically save points or templates that you want to keep. So let's say I took an empty machine and I installed a I don't know, a BPM on this machine, right? BPM itself, it takes a few minutes to install, but I don't want to repeat the process. So what I can do, I can power down the machine and save a snapshot of that machine. Oh, sorry, not snapshot, save an image of this machine. So later, I can take this image and create as many machines with installed BPM as I like. So my next step would be, after I provision the machine, is just to integrate the machines to the places that I want. I don't need to go through the same process. So so images are basically templates if we are going to compare it to the VMware world. Snapshots are not the same as they work in VMware. In VMware, you can create a snapshot of every machine by just right-clicking it and selecting a snapshot, and that's going to be your save point, right? So normally in VMware, let's say you want to install some software, and you say, well, you know what, it might not go the way I really want it to go, and I want to have a way to go back to previous state. So you right-click, you create a snapshot in VMware, and in case everything is not working well, you'll go back to the snapshot. Now in AWS, it's going to be the same in terms of the snapshot and what it contains, but in terms of actually recovering the snapshot, this is not as pleasant. So it means that we change approach. In VMware, we can always rely on our ability to go back and repeat the steps. In AWS, we are not as relying on that, because switching snapshot to go back to a previous state of the machine is going to be just too much effort. So we must take the approach of environments that can be easily burned. Okay, I'll give you an example. Let's say you create a machine in AWS and you created it in the wrong size. Instead of 8 CPUs and 32 gigs of RAM, it's going to be 2 CPUs and 4 gigs of RAM. You're not going to be fixing this machine. You're going to be deleting it and creating a new one. That's the approach. That's the general way of dealing with resources in AWS. So it is a little bit different compared to VMware. Okay, so here's, for example, an example of images, and there are some images that we created for you for this course to save some time. So there's going to be a data flow probe, there's going to be a site scope, BPM, and an edge component. Right, and snapshots, they basically look like this. There's just saved hard drives of sort. So to use a snapshot, you might actually need to detach an existing hard drive from a machine, attach one of the snapshots, which needs to be converted into a volume. And then, as you see, I'm saying a lot of things that don't make sense outside of the context. So if you never operated the EC2 environment, now it doesn't make any sense. And for a good reason. We are not relying on snapshots as a save points compared to VMware, so we're not going to be treating them as an option. Okay, now an interesting point or interesting thing that we do need to stop on it and actually have a little bit of a demo as well is EC2 security groups. Well, they're not just EC2, they're VPC security groups. Now, normally, you would have several elements for security. One of them would be a system-wide firewall inside your network, which says, well, what kind of communication is possible between entities in a network, right? So let's say you want to restrict external access to port 443 or something like that. You would do it with a firewall in a normal environment, okay? There can also be some internal rules for the firewall when when machines are trying to communicate with each other, but usually they are not used or exposed, at least not in my practice. This is not a way to go. So usually what you have is an external firewall that has rules about external access to the network. And then you have internal firewall on every machine that needs to be tuned, right? So let's say you create a POC for a customer and you ask IT to open firewall rules for port 30001, 443, 8443, 383, all of those nice OPS bridge ports, right? And that's about it. Now in EC2, there is an additional entity in between. It's called a security group, and security group, as you see from a diagram over here, is basically a governing factor that sits very closely to the instances or the machines that participate in it. It's like a separate entity which we control most of the time. Don't get me wrong, we still have like a default firewall on Windows machines, but if you're using a Amazon Linux as your Linux type, it has its firewall turned off, and if not, then for most of our purposes, we never get to touch it. We don't need it. But security groups, oh boy, we're gonna be dealing a lot with security groups. Security groups is something that we would be using to restrict access to our resources. And this is what the CyberRes team in Micro Focus IT is monitoring. All of the security groups that you're going to create, they will be looking for internet-wide access of 000/0. And the security groups, they involve several rules. The rules go from simple ones that look like firewall, basically port, protocol, and destination that is allowed to access. Same goes for outgoing rules, but you can also include whole subnets or other security groups inside it. And it is not separated conceptually from firewall, but you need to understand that in normal situation, you would be operating firewall on the instance, on the end VM, or on a network as a whole. And we do have it. It's like a network ACL, and there is another firewall that you can implement in AWS. But most of the security is done in security groups, which is kind of a separate entity that sits between your machine and everything else. Okay, so let me show it a small demo of security group before we continue to something else. We do want to be consistent. So here I am in the EC2. Those are VMs. When I'll go to security groups, I can actually select any one of them. Let's say, for example, EKS control plane. That's an automatic group that was created. And when I go to inbound rules, it says, well, you know what? This group has access on the IPv4, HTTPS protocol, TCP, port 443, and anything with this CIDR can get access to this resource. And basically it means that that's all of the internal network or in this address space. Fantastic. So that's a simple one. Let's try and see if we have a more complex group. Let's see, something more spicy. There it is. This is one of the automatic groups that is created by by automation that we are going to operate. And look at that. Now suddenly you don't have just a security group or a firewall rule. You have a full rule set that governs practically all of the routing inside your cluster, right? Certain ports are defined individually to specific CIDRs. Certain ranges are defined specifically. Some of them are restricted to specific groups, and some of them are just widespread accesses to whatever you please. It is just all over the place, and you need to be always be aware about what kind of rules implemented on top of each of your resources. Another way to look at it is if you go and select one of the VMwares, one of the virtual machines, and you'll go to Security tab, you will see that there is a security group attached to it. This one is called internal external access, and then you'll see that it's a bunch of IPs for specific ports, but basically there are port ranges. And so you can say, you know what, anything within this range can access anything for the machines that are attached to this group. Okay, fantastic. What do we do with that? Let's say I want to investigate why this machine cannot be accessed from outside. This is where I'll go first. I'll go read the security group and I'll say, you know what, from outside, okay, everything that is not 10.0 or 1730 actually has 1 IP, 2 IP, 3, 4, 5, 6, 7, 6 IPs, right? Only those 6 locations can access on all of the ports, and only this port is available for the whole internet. So immediately all of my, let's say, communication restrictions are exposed to me visually. So this is why the security groups are so useful and powerful. Okay, and that pretty much covers them. So always be aware about them. They are in fact, for all intents and purposes, are a firewall, but they are a part of everything that you're going to be doing. Okay, it's very rare to see in AWS that all of the resources are just exposed for all of the ports, for all access, and that's it. We're not treating it this way. We do try to keep it as tight as possible. So that's the security groups. Now, let's talk about load balancers. Now, load balancers in general, of course, there are several kinds, okay? There are application load balancers, there are network load balancers. In AWS terms, there is a classic one, right, which is not used, but is provided to you, so they separate the mechanism from one that they used before and one that we have right now. And there are several things to consider when you operate the load balancers. Load balancers have targets, they have listeners, and they are also attached to specific VPCs, ports, and protocols. Okay, so before I actually get to show you the demo of it, let's discuss some theory, right? So this is a simple network diagram. We have the client, be it your laptop or anybody else's machine or mechanism that connects to whatever resource you own, right? And there is a DNS, of course, and then the load balancer that can choose between, let's say, resources in multiple availability zones. Pretty normal situation, right? So the client would go ahead and request opsbridge.com. It will go to DNS, and the DNS would actually send it to another DNS name. We can say it sends to IP if you really want to, but DNS includes A and C name records. So it would refer to the DNS name of the load balancer that is responsible for port 443, so HTTPS, right? Load balancer is listening on port 443. And when somebody reaches it on this port, it will decide to route the traffic to one of the locations that are attached to this port. Those are the targets. Okay, so the target for port 443 is one of those three machines internally. This is a very, very simplistic diagram, which we need to complicate a little bit. Let's discuss another scenario. I go to the same URL. I go to the same DNS, the load balancer DNS address. Load balancer is listening on this port as well. Same load balancer as before, but a different port. And to it, the target is different. So one load balancer can have multiple listeners that route traffic to multiple locations according to some specific rules. So far, so good. Now let's discuss it in more technical or realistic terms when it comes to OPSbridge. Now, the client is going and asking the opsbridge.com, DNS is listening, it sends to the external load balancer name. And this load balancer is listening on port 443, but it forwards all traffic from 443 to 30443. Okay, which means that the targets themselves are not listening on a direct access port like you used to. They are listening on a dedicated port of their own. And actually, this target is pointing toward internal load balancer, not directly to those machines, but an internal one, which in turn converts, it listens to traffic on 30443 and forwards it to a traffic 31224. Now, why I'm saying all of those numbers, they don't make any sense. And it is true. Let's untangle it from another end. When we deploy the OPSbridge suite, first of all, a infrastructure is created. You get your VMs and networking set. And then you deploy your OPSbridge suite on top of it. And when you deploy the OPSbridge suite, some of the ports, some of the listening ports for services are basically chosen from a range of ports. They're assigned and there will be different between every single student environment. This is why you cannot just copy paste some of the things, and you need to adjust it when you run your configurations, right? So in this specific situation, that's the one that I copied from my own environment, the automatic port for normal traffic, like where's my OBM, where's my BVD, right? The automatic port that was chosen was 31224. And then later, when we deploy our OPSB suite, we also run a script that creates all of those load balancers for us. And those load balancers, they have listening rules of their own. Some of them are predetermined, and some of them, during the configuration, it goes to the OPSB suite. It asks what are the current ports that are relevant to the current setup, and they create a bunch of forwarding rules, basically a combination of a listener and a target. And now we have a chain. So basically, client goes, gets a different DNS name that's not reflected in your browser. It gets to external load balancer. It gets to internal load balancer, and only then the traffic gets to one of the workers in this situation. Okay, so it gets really complex. And why are we spending so much time on load balancers? I mean, it's like, what is going on? So before I answer that question, let's discuss another example, right? This is the Optic Data Lake receiver URL on port 3001. And now I'm actually going to substitute it with real examples from real environment, right? So it goes to this DNS name. The name of opsbridge.com gets substituted for all of this, and the port is still kept, right? When it gets to internal load balancer, the port 3001 is translated, well, the load balancer is listening on 3001, but it redirects traffic to port 5050 of this internal load balancer address. And this load balancer, it listens to port 5050, it routes the traffic through to this automatically designated port from the setup itself. And then it routes the traffic to one of the targets that listens on this port. Okay, so this is the main example of how the traffic works. But now something weird can happen. Okay, what happens when you route traffic and the load balancer has multiple targets, and one of the targets is off? What's going on? So in normal terms, the traffic would be routed to one of the other locations. But there are multiple ways in which the source or destination can be unavailable. One of them is it's completely turned off, no machine. Okay, well, in that case, the load balancer, it has health checks, and health check would say, well, this is not a healthy destination, so I'm not going to use it at all, which is fine. But sometimes the destination is available. It's just that the requested resource is not. And in that case, well, normal client would go and say, you know what, I'm going to call for the URL. I'm going to go through the whole thing. I'm going to hit a server that is there but doesn't give me what I want. I'm going to try it again. And the load balancer would go ahead and in a round robin fashion would go and put traffic on some place that does correspond to us. Which is fantastic. But not all clients are able to reinitiate this process, this whole thing from scratch. Many of them would just go to one single place and they stay. They just stay. They never leave it. They never reinitiate communication. And this is a very, very, very relevant to the cloud setup that we are going to use. Because in the OPSB suite that we're about to install, the default choice is to create everything in one availability zone out of two that we have available, and which is fine. But the load balancers that we're going to create, and we don't control the process, they would be created for two availability zones instead of one. So now when something doesn't work, we need to investigate it in from load balancer perspective as well. It's not just simple traffic from one place to another. In the on-prem environment, you were using load balancer as an entry point for high availability environments or mature environments, and that's it. Here in AWS, this is actually something that you just get to use from the very beginning. It's just part of the normal setup. It's not an extra feature that you add to your setup. This is actually something that you operate from the very beginning, and it's an active component of the whole setup. Okay, so let's recap this scenario real fast, right? Under good conditions, the first attempt to communicate, the communication is established to one of the destinations, and we're not talking about a resource that is turned off. We're talking about a resource that doesn't have what you need, let's say a file on it, right? So target is not responding or not giving me information. I create a new attempt, and in the new attempt, a new connection is established, and target is responding. Hooray! We're done. So an example would be you knock on somebody's door and you ask people if John lives there. They say no. You say, oh, okay, and then you go ahead and knock on somebody else's door, okay, until you find John. Now, the scenario that can happen in many situations is when the first attempt goes and it finds that the destination host itself is up. The machine is there. Okay, but you don't find what you need. The target is not responding to your request. So instead of reinitiating the second attempt, it keeps the first attempt, it keeps the first connection, and it just keeps asking the same resource over and over and over again. So an example would be knock on somebody's door, ask if John lives there. If they don't live there, you just keep asking the same person without closing the door if he still lives there. Now, why? We go back to the question, Alexei, why have you spent like 1/3 of AWS basics on load balancers? So let me show you. Here's, let's take into consideration several things. First of all, we have VMs, right? Second thing, those VMs have a bunch of rules. So the security group here says, well, I can get on this port range from this location, and basically a bunch of restrictions, all of which I need to be aware about. Some of them I would have to create manually. But then we get to the load balancer, and the load balancers, they skip the security groups. Okay, so let me show you. For example, this is those are two big load balancers for one of the student accounts that we use for testing. Okay, and basically it listens to port 443. It directs the target traffic to 30443, exactly as we discussed. Let me zoom in here a little bit. Right, and then when you click on it, you'll see that the traffic is redirected to some specific IP. Now, this is another load balancer. This is the IP of internal load balancer. But the point is that all of this traffic, for some very convenient reason, goes from your browser to the load balancer to an internal load balancer directly to the source. No security groups involved. Okay, and for anybody that is going to manipulate an AWS environment for a little while, they can say, whoa, this is very convenient, because I get to say how I access from outside. I don't need to create rules and attach them to every single machine in the cluster. Let me show you what I mean by cluster. So I'll go ahead and search for student 83. And you might notice that it has all of those machines. So those are the workers. So now I need to configure and define a security group that allows me specific actions. And on every one of those, there is the Bastion, there is the Vertica MC, and there is Vertica itself. Now it gets very complicated. I need to manipulate multiple rules to just add some extra functionality beyond the normal installation. And then you go to the load balancers, and knowing all of that you need to perform all of those loops and hoops, you see that the load balancer gives you access without dealing with that. You just set it up once and you get access to everything directly where you need it, how you need it, without putting all your marbles in multiple locations and trying to figure out how to untangle all of that. That's temptation. And the reason why we explain the load balancer in those specific terms is to explain that load balancers are not able to cover everything that you need. They must have a presence. They must have a component that corresponds to your communication attempt. They must have it in every single availability zone. Okay, load balancer is not looking for what you need for you and then serves it to you. Load balancer just provides you a way to connect to it once, get it, and then on your next attempt, it might send you to a wrong location. And for complex environments, it means that it might just not let you work in general. It just might not let you do the things that you need. And now an example is in place. Okay, let's say you have an OPSBridge cluster. And this OPSBridge cluster, well, it has pods, and every pod has some specific action that it performs before it decides that this pod can work. And if this pod performs several of those actions, and it connects to the load balancer that doesn't serve it the things that it needs, it will just fail to start. And it happens. Same things happens, for example, if when you will be doing the exercise with custom metrics, without specific alterations that we, the instructors, did to one of the environments, half of the time it just doesn't work. Because half of the time it goes to a location which the load balancer just cannot, it cannot determine that it doesn't work, but it will also give it to you as a response, right? So to recap, load balancers can bypass security rules, but we are not doing it intentionally, even if we have the choice. Okay, I'm stopping on this specifically because, oh boy, there is a lot of opportunities for you to decide to architecturally approach this from load balancer perspective. Okay, let's talk about EC2 itself. Like we said, this is the VM management. So let's create an instance. And creating an instance is very easy. You click this launch instance button. You'll give it a name, for example, Alexei test. Right, and then you get to choose from default pre-selected few operating systems, right, from Mac OS, Windows, and some of the mature Linux distributions. Or you can get access to all of your images. So, for example, let's say Sitescope, okay, or something like that. That we created it. That's us. That own this AMI, or we can even go to the marketplace and we'll say, you know what, I want to have a image that has, let's say, I don't know, one of the competitors. What would it be? Nagios. Okay. I want an image that already has Nagios installed. Somebody configured it for me. I just want an image with that stuff on it. Or right now, I click the provide button and I get it. So you can do all of that. You see, then you have a multiple choice. So we're not going to select Nagios, but right. So let's continue. Alexei test. So you get to choose your image, and the best Linux to use is Amazon Linux. It's well documented. It's stable. It's maintained by the professional team of AWS engineers. So there are not many reasons to not go with Amazon Linux, and also it's based on RPM or YAM. So it is compatible with most of OPSBridge software. Then you get to choose what is the size of the image. And as you see, it already includes a price next to it. So for example, the one that is micro is 1 CPU, 1 gig of memory, and sometimes it is free. Don't look at that. We're using an enterprise account, nothing is free. But you get to choose your size. So I can say, you know what, T3A medium. And T3A medium, it means that it's going to be 2 CPUs, 4 gigs of memory, but it's the letter A says that I'm using AMD processor to save some money. Just you know, as a way. Now, another thing is key pair. Key pair is a basically a configuration, certificate configuration in AWS. The AWS keeps a copy of the key pair inside, and when you select it, it's basically you choose a certificate that you need to use to connect to whatever you create. Now, one of the requests from previous lab week in Europe, they asked, well, Alexei, where do I get the key pair? And in the lab environment, I give it to you because I control the environment. In the POC, the customer would give the key pair to you, unless there is some scenario where you just give you an account and say, you know what, I don't care, this is a small account created just for you, you do whatever you please. Then you'll go ahead and you create a new key pair. For example, you see, I can press this button and it will just ask me for the name of the key pair and the tags if I really want to, and that's it. It will automatically generate a certificate that I must keep. I cannot lose it. I cannot download it the second time. There is only one opportunity to download the certificate that AWS is going to generate for me, and this certificate would let me connect to my VM, right? So in the normal scenario, customer would give you the key pair because each key pair costs some money, not much, but you don't want to create a new key pair per every new machine that you create. So I'm going to use the one that is called OPSB WABWIX. Now you get to choose your VPC. Again, I'm not expecting you to remember that. I'm expecting you to acquire a list of idioms or I don't know, references that when you get to see it in the exercise, then you'll say, oh, well, this is not the first time I see this, okay? So here I get to choose the VPC, and I'll choose the one that's called enablement VPC. Okay, I will choose a public subnet, not a private, because I want a public one that is accessible from outside, and it will automatically assign a public IP. Then it asks me if I want to create a security group or select. I recommend to, unless this is like the first VM ever in the whole region, do not create a security group here. You will select one, and I already have the one that's prepared. It's called init server, which is basically a group that allows us to connect to machines from our VMs or from our own laptops. And then I can choose how much hard drive space I want, let's say 30. Okay, now there are advanced details. For example, I can put a script that actually runs here at the end of the creation of the VM. We're not going to touch that. And I get to select how many machines I want to be created at the same time. I just want only one. So I create on launch instance, and I can see the status of this instance when I click this button. As you see right now, it is creating. If I will select it, it already has a public IP address, which is very convenient. So I'll go ahead and I will open the Windows Explorer, right? And I want to connect to the machine using PuTTY. Where's the OPSB job? Okay, so I downloaded a PuTTY exe client. You'll do it in the exercise as well. And you can use either the visual way of connecting to that machine, or you can use the command line, which is I prefer it a little bit because in the visual way, you basically need to configure it here. You need to configure the SSH authorization section. You need to go back. You need to save. You see lots of steps. Instead, I will go ahead and launch a where is it? PowerShell. Where is it? Yeah. Okay. Let me just do this. I open the CMD. I'll go to C OPSBridge Web. And now I just get to say PuTTY exe minus I and the name of the certificate in PPK, right? So it's going to be OPSB Wabvik PPK. And now I need to go ahead to my EC2 over here. And I can, for example, either create a connection string myself if I'm familiar with it, or I can go to Actions, Security. I get to connect. I go to SSH client, and as you see, it already has practically the whole thing for me stated here. But because I'm using PuTTY, I cannot use the PEM. So I'll copy the whole connection string, the username and the address, and I will put it here inside my command line, and it will ask me, well, this is the first time that I ever connect to this thing. Do I accept the certificate? And it says yes, and then there it is. I am now connected with SSH. So instead of going through a complex setup process, all I have is a command line that gets me access there. Now, you might, those of you that are familiar with the mechanism will say, hey, Alexei, that's not convenient. This is just a one-time thing. And to which I say, correct, true, but convenience is achieved through external tools. You are looking at one of them that is called mRemoteNG, and I recommend it very much. It allows you to duplicate sessions many times, and it allows you to control and select them, and it is very convenient, but it requires some extra steps for configuration. So not everybody are able or allowed to install software on their own laptops. Okay, so this is how we create an VM, we connect to it, security groups and load balancers. We pretty much covered it. So now the quick bits, like the cool guys say. Previously, we discussed two very heavily used mechanisms, right? One of them was VPC, which is the whole network, not a small thing. Another one is virtualization, EC2. And then, of course, the combination between them is the access, be it security group or load balancers. Now, there are other mechanisms in AWS. For example, Route 53. This is basically a DNS manager, and this DNS manager has two configurations. One of them is a public, basically how the publicly accessible DNS addresses are translated to aliases or IP addresses, or private, which is used by your VPC to communicate inside VPC, right? So private domain names and stuff like that. And the main things that we need to know that there are two parameters: CNAME, change name, which means that if I use one DNS name, it will change it for another DNS name. And a record translates a DNS name into IP address. That's the majority of the differences between them two. So let me show you a really quick demo. I will go ahead here and I'll search for Route 53. And there is a reason why we're going to be covering it pretty fast. Route 53 is the place where you buy your domains, right? You can register domains, but once you do, you have hosted zones. And there is, for example, this is the hosted zone that we bought for this course. This is where you're going to be operating part of the time, and it's a public one, right? There is also a private hosted zone for every single Kubernetes cluster or VPC that we are going to create. So right now we have 3 of them. By the end of today, there's going to be 26, 27 of them, right? So it goes, it expands pretty fast. But all you need to know is when you go on the inside, that's basically a DNS record. You have the URL, you have the DNS name, FQDN, you have the IP address. That's an A record. You have a CNAME. Don't look at the addresses here. They're confusing, but CNAME is basically the DNS name for DNS name. And this is what defines external access from your laptop. When you will go, for example, for student 23, it will go to this public load balancer IP address and translate all of the addresses. Without this, there is no way to get from outside. And next is the EKS. Now, what is EKS? If you ever work with Kubernetes, this is the managed service for EKS. Why use one of the AWS and not one of your own, let's say a master node? There is a very good reason for that. They maintain it, they keep it up, they fix it for you, and it is conveniently available, and it is fine-tuned according to the best of your interests. It's as standard and generic as possible, and you don't get to maintain it, you get to just use it. So the EKS cluster, in most perspectives, it's just a hidden VM that has Kubernetes installed on it, and you get to interact on it. So we're not going to be lingering here a lot. While EKS is very important, and if you'll get to one of them, you'll see that you get access, same thing as you are familiar with Kubernetes from command line. You have pods, replica sets, you have your nodes and namespaces, and you can see the networking and the logging and all of this, and we never go here at all. We just don't. There is no single reason for us to go and manipulate anything from the UI. All you need to know that it exists, but that's about it. It's a managed service which you don't need to control yourself. Okay. Now you will have a Bastion node as part of your setup. What is a Bastion? That's basically a command line connection to a cluster that you're going to create. That's all. That's all the machine is doing. The machine is connecting with the command line to your Kubernetes cluster from a safe location, instead of you going and operating it here with limited functionality, or instead of going to your workers, which should be doing only the worker stuff. There is a separate small machine that your cluster is going to deploy, and that's the Bastion node, which connects to all of those things from a command line. Okay. Now, let's go to the last one. It's RDS. RDS is a relational database service, and like everything else, it is very convenient. Why do we need it? I mean, I can create a VM, and I can install Postgres on that VM pretty fast and just use it. Why do I need RDS? Especially considering that RDS costs twice of its compute size, right? So every RDS basically has a size like any other machine. And T3 extra large, it means that it has, I think, 4 CPUs and 16 gigs of RAM, maybe I'm mistaken, right? And what RDS is. So normally you would install your database server of a specific version, and then you need to maintain it, be it backups and tuning for specific use and connectivity and security. And there's a lot of life cycle. This is why we have DBA people, right? So in managed services in the cloud, what they do have is a bunch of templates that are available to you on demand. So you basically, when you create a database, or when your automation creates a mechanism, you get to say which one of them is it, what is the version that you want, is it going to be production, dev, test, or free, which determines how much you're going to pay for it in where it is located. So if it's a free tier, probably you're going to be like on some server in the backyard of Ohio, just lying around on the ground, but you get to use it for free. And then you get to use basically a nice web-based wizard to set up the database name and everything else, and credentials and sizes and storage and all of those nice things, including security groups and networking. Now, if you would do it manually, you'd be spending a lot of time on that in your VM environment. So what cloud is doing, in the cloud, they just create a very convenient way to do all of those tasks without being a DBA engineer. Okay, and the last thing that I'm not going to show you is the IAM. Sorry, this is the access manager. This is the user management part of the AWS, and it's pretty much similar to our IDM in the OPSB suite, because it has usernames, it has passwords, it has groups, it has roles. The only thing that is different or very convenient in terms of the IAM in AWS. Second, I need to handle some noise over here. Who is not muted? There we go. Okay, so the only difference is that you get access to the JSON definition of the security functionality, and because of that, the number of options is expanded. The visual mechanism doesn't allow you access, for example, to restrict a specific user from accessing only the Ohio region, like here. In the JSON format, you get access to every single entity, and you just get to expand it. And it's not part of this course because this is probably where the customer would be doing their job for you, and you would probably never get access to AIM because it's the backbone of security. And if customer controls anything, it's that location. Right, so I'm not going to show it; it's not relevant. But so you know, there is a lot of control about what can access where and why. In all of the cloud providers, it's much more mature than any other user management platform that we use in products, for example, and probably you're not going to control it. So that is mainly what I got to say about AWS. Let's summarize, right? When you compare on-prem to cloud, most of the underlying technologies are the same. There is a difference in terminology and the names, but Kubernetes is still Kubernetes, storage is storage, VM is VM, network is network. Okay, but there is a difference in approach. In VM, you might create a VM, you might restore a VM, and you might fix the VM. While in the cloud, you would just delete resources and create new ones, because it's just so much faster. I mean, you have seen me creating a machine like 20 minutes ago, and between creating the machine and connecting to it, it can be less than 1 minute. In VMware, you're not going to be that lucky. Okay. Of course, also the approach is different. In on-prem, IT manages everything. I have spoken to many professionals that spent decades working on customer environments, and they struggled with understanding how VMware console works, which is completely understandable. They are not given the opportunity to operate it. Okay, in the cloud, that's not the case. All of those UIs that I showed you, they're not theoretical. They are part of what every operator in the cloud is going to be doing. Okay, so definitely many new skills to learn, right? Now, what is the difference, or what would be a good example of why we had the on-prem and now we use the cloud? And one of the examples from the past was when we moved from normal VMs to containers. Right, so if previously to operate a product, you needed to know Windows and Linux, suddenly containers were introduced, and now you need to know Docker, and you need to know Kubernetes, essentially, and then some nice things like Helm attached to that, right? Suddenly the skill grows, but you get the benefit in containers of having everything containerized and predetermined and pre-configured for you. So same thing goes with the cloud. Right, compared to on-prem. In the past, you didn't have much control, but now you do have a lot of control. But many of the processes were simplified. Right, in the past, you had a storage engineer and a DBA. Now you get to be the guy that operates all of it, but without necessarily having exactly the same knowledge level or responsibility like those guys did in the past. Now let's discuss some of the best practices. This is how we share experience with you. I consider it to be very important because, like anything else in IT world, it's either you get on the end result or you work on manipulating the platform or operating the platform, and you spend your time clicking the buttons or figuring out stuff instead of getting the end result. Okay? meaning that, if, let's take a simple example. If you install something, let's say Microsoft Office, you just click next, 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 and it's done. And you don't need to read every single component. You just need to where the button goes, right? Instead of imagine to yourself if you would have to deal with every single next button by reading everything that goes in there. So there are many, many methodologies which allow you to save time by just having some basic assumptions or some axioms about what you're going to do, right? So first of all, always be aware where you are in VPC. If you place a machine in a different VPC than the one that you need, you might investigate a lot and put a lot of effort in terms of why is it not working while it should. And the only place where you will find out is when you go to all of the instances. You can choose your instance, and someplace there in the networking, it's going to say the other VPC. Everything else would be fine, except for just one place, VPC, right? So always be aware where you are in terms of VPC, because you will be operating in an environment with 20 other students. Okay. Now, understand this: the front end, all of those buttons here are an addition to the CLI. Automations are the main topic of cloud, right? So when you get to press all of those buttons, although they are nice, they are not the main focus of the cloud developers. All of the things that you can do manually, you can use a CLI, which we're not going to be using because we're not running automations or creating automations. But please understand that CLI gives even more access to even more things in the cloud. And when you get frustrated with the front end, please understand it was never built for you to navigate 300 machines at the same time, belonging to 20 different VPCs. That's not the intention. This is like let's say, a development platform. This is where you figure out stuff. But realistically, the cloud is based on an approach that you would be is eventually automating something. Okay. Now, the search. Always use the search. You go in some place, search for it. Okay. Just search for it. There is a lot of clutter to be avoided if you will go ahead and you'll use search. I mean, you go to load balancers. Can somebody understand what's going on here? Nobody can. But I search for student, and suddenly I get everything clear in front of my screen. I need to access a different service. I'll go ahead and just search. I configure a new machine. I'll just search for selecting even the most basic stuff. For example, the key pair. I'm not going to be using the drop-down list at all. I'm going to be using the search. I'm going to be using the search in VPC. Okay, sorry. Because when the list gets long, you would be spending a lot of time on trying to figure out what is in the list instead of getting the end value. Please use search wherever you can. It's going to save you everything. Okay, and always be aware about security. Okay, now to make your life easier, I recommend very much to use a session manager. There are so many of them. Some people use MOBA Xterm, some people use mRemoteNG. There are a bunch of other free tools that allow you to connect to multiple SSH sessions and keep them instead of using the command line. If you have a clipboard manager like I do, for example, here's an example. I get access to everything that I copy pasted, and I can use search to just get access to everything that I use in my clipboard. It's very, very fast compared to any other way. Okay, again, we try to maximize the time spent getting the value and not operating the product, operating the cloud itself, right? You search everywhere you can. Keep a notepad on the side. Everything that you need to be keeping on a side, just keep a notepad. That's very useful. The screen size and resolution is very important. You might notice that I have a lot of real estate when I operate the environment. Okay, I have even this is zoomed. That's how I see stuff. Okay, this is a full HD monitor, 17 or 18 inch that I have, and I get access to everything very fast. I can click multiple tabs. I understand that some of you have very small laptops and you'll get access to this kind of view. which is not a lot, I understand it. So if you have the option to connect to an external monitor, or maybe to zoom out a little bit until it's inconvenient, just, you know, the more real estate you have, the faster you get, the less frustrating it gets, the more effective you are. Okay. Another thing is RDP. When you operate an RDP in a windowed mode, let's say you don't have a session manager, but you do have an RDP, right? If you have an RDP file, you can go to, let me show you real fast. Where's archive? You can go to RDP, right click it, say edit, and instead of having it on display with full screen, make it 1 or 2 ticks smaller, because it will allow you to go to your web browser and RDP, web browser and RDP, switching between them really fast. When you do RDP in full screen, you're gonna get lost. I've seen people spending like 2/3 of the time of the exercise on just clicking between RDP and their web browser on their computer. Okay. And also, very good tip is multiple browsers, multiple tabs. Now you might notice that I have Firefox here, and I have a Vivaldi. And probably by the end of the day, I'll have also an Edge open. Why? Because they occupy different space in my taskbar. To me, it's very convenient to understand that this is everything cloud related, and this is everything documentation related. I don't need to guess myself. I don't need to go here in my Vivaldi and navigate multiple, or I mean, it is designed for speed, but imagine yourself, you have 30 tabs open, right? Navigating between all of them to understand, okay, here I have my documentation, and here I have my EC2 console, and here I have VPC. While all of them are the same, it's gonna be costing you a lot of time. So please use separate browsers for separate tasks. It will just create a lot of speed for you, and you will be enjoying the platform, because I'm going to tell you right away, AWS is pleasant. It is nice to work with, but only if you have the space for it. That's my message to you. And I think this is time for me to stop talking. So I'll stop the recording and I'll take questions.